Good morning to all. Uh, in this session, we will continue with the rest of the parts of this screw jack assembly. Now we have already done the two parts in previous session. Now we will look at the third part, that is screw spindle made up of ferrous 410W is the specification of this material. Uh, This is the part drawing. It requires 240 mm diameter length, sorry, the 65 diameter of cylindrical part with 240 mm length. And here, just go to your solid edge screen. Go to solid part, and you can use any plane. Here, he has given this drawing. It looks like a in this figure he has shown it is not it is just a detail in his side view. I think it is horizontally kept due to the space constraint here. So I will use any one of the plane here. I will choose XY plane here, and I will draw the 65 is the maximum dia, and then go back and you create. Here you can create this symmetrically. 240 is the length. You see here the dimension, the length of this cylindrical part is 240 mm. So here once you click on this protrusion, there are numerous options will come here. Okay, we will use one by one as the situation arises. Here you just see this protrusion dash symmetric extent. The moment I click on this, the material will be created symmetric to the this plane. So equally it will distribute the material. In the distance command here, you just type 240 and fit it. You got the material that is required for this component. Just hide this the sketch. Now look at this drawing, out of which this shape is. Now you can take the circle command and remove the material using cutout option. First the 22 diameter of how much, here he has mentioned 13 mm depth. Okay, so I will remove that material and keeping 22 as the control. I will consider this as my top face, and I will draw a circle of 22 diameter, and then now use this cutout option, and then click on this sketch and right click and use this side step as we did for the second model. It will ask the direction, and the outer side of this circle will be removed, material will be removed. How much you saw it, 13 is the depth, so I will give 13. So 13 diameter, this 13 mm depth, the material has been removed. And then now look at the drawing again here. After that, from 83 mm, apart from this, the 65 diameter is maintained up to this 83 mm. After that, this diameter is 38 into 7. This thread is, this spindle is going to be in this gunmetal nut. So this same threads are drilled here, and now we have to maintain 38. So I will go to the bottom face. I will pick as my sketching plane. I will just draw a 38 dia circle, Go back. Now using same cutout option with side step, activate this side step icon and you give overall length is 240 minus 83, retain it and just say enter. Your material is, here he has mentioned some 10 into 45 chamfer. So before that chamfer, you look for the other aspects. What are the other picture? There is a 12 dia hole over here, and there is a countersunk hole here. This is called as countersunk hole, and it is it is a threaded hole. M12 metric thread is drilled over here, and total depth he has given is 35, and 30 mm threaded portion is there. Total length of the bolt is 35. So we will drill this hole first, and then we will drill this hole. After that we will look for the chamfer and threading this shaft. Okay. So first M12 thread we will try to uh, mm, drill here. This before seeing this hole, you just in this screw will be screwed into this countersunk hole. The angle you see here, angle you will get from here, countersunk hole 90°, and the diameter of this countersunk is 24. So you just go to the model screen. So zoom this area and then go to hole option and pick this top face, and you will be entering into the sketcher mode. Here go to hole options. So here you see a counterbore, countersink, tapered, threaded. I want to drill a countersink hole. So take this countersink hole, convert this into mm. Then the diameter is it is mentioned in the drawing as M12. So take 12, and here countersunk diameter will be 20, 22 is the outer dia. Less than that you have to take 27 or something. Thread you have to mention here. This is M12, M12 thread you have to mention, and up to hole extent, finite extent you have to here mention, because total hole depth is 35, the threaded portion is 30. So finite extent I will use 30, and hole depth he has mentioned here. Finite extent means hole depth will be active. Hole depth is 35, and then you the last end of this you can use this option, and V bottom shape will get 35 is he has mentioned up to this shank dia. The V bottom he has left it like that only. If you zoom it up to this 35 is there. So I will activate this command. Okay, now say OK and place this onto the center, and return your drilling operation has been done. You just keep it on the front view, and you see here I will show you this countersink hole has been drilled. You can edit, because this has some countersunk diameter you have to decrease, because 22 is the outer dia, so I will decrease it. But you can edit your feature by clicking this on the particular feature, mm, and edit definition, edit profile. You can edit the sketch of that by right clicking here. And now go look at the drawing here. What is left? There is one hole here. I will choose this YZ plane, and I will draw a circle here, and diameter is mentioned here 12. That is, I think this Tommy bar will go inside this to give the torque. This hole is introduced. 12 dia hole. Just make sure that it is 12 dia hole, and you have to locate this from this edge. This is 35. So from this 35 means from the bottom edge. Before that hole, I feel it is better to give the chamfer here. Select this edge, and it will ask setback distance, that is 10 mm he has given. The 45 is angle is default, it will take. So before drilling that hole, because I have to use this edge as the reference 35, so I created this chamfer before drilling this hole, otherwise it will create a problem. Keep it the similar chamfer is here. You just give that chamfer, and then now keep it on the front and choose this YZ plane from here, or from clicking it or here. Then now draw this circle of 12 dia, and now you can position it by dimensioning it 35. Okay. So at the center I have drawn this profile using cutout option. Select this sketch and use the symmetric extent. The total diameter is 65, you give 66. You can see the hole has been drilled into this. Okay. Okay, now the rest of the things are only left is the threading portion. So here 3 mm gap is there. Apart from that, the whole shaft is threaded. So you can use here in the initial previous session I have showed you how to drill use a threaded portion. Here thread icon is there. Before that you give here a chamfer of 2 mm or 1 mm. You cannot leave the sharp edge. Here under the hole option, if you beside this one arrow command is there, you can see this under this thread icon is there. You can use thread onto the shaft surface. Pick the cylindrical part, and then starting point you have to mention here, and then you choose the diameter and the square thread. To cylindric extent he has mentioned. So here this is 240 minus 83. I will just 157 minus 3 mm will be 154 is the threaded length. So I will give the finite value here 154. So here the thread surface thread has been made, but thread feature has come into the specification tree. As I explained, it will look as a green surface. Uh, you don't see the actual threads here. And now look for any other operations are left. So there is no operations left here. So you can, I think this model is finished. You can see it in wireframe entities, whether the holes you have drilled are correct or not. Okay, so model, I feel this is okay as per the dimensions. Now go to tools, hide all your reference planes, and then if you want to change the color of this, so now save it. I didn't mention in the beginning, so you have to mention it in the beginning itself. Its name of the part is screw spindle, and its number is 3, and say okay. And here I will give 003, save it, and I will add the material. It is Fe 410W wrought iron. Apply to model and save this. Okay, so I hope this is clear. Practice this in home, and in laboratory hours you just practice this using this solid edge. Only thing, this CAD is a skill for every person of any age or any experience. Uh, Once you leave this for a long time, it will for every person, for any experienced engineer or a fresher, he will feel difficulty in operating it. So keep practicing, because time duration in examination is 3 hours for 3 questions, where this part C takes a lot of time. So you have to, only the way is to uh, keep practicing by estimating the hours required to create this model, and then you will not have any problems in your while executing these assemblies. Okay, we'll meet in the next session. See you.